A warm welcome to all of you, my friends and students. A very good morning, good afternoon, good evening to all of you. And as you know, this is the Data Analysis and Decision Making 1 course under NPTEL MOOC, and this whole course is for 12 weeks, which is 30 hours, and we are in the 42nd lecture of, starting the we have already completed 8 weeks. So, we are starting in the 9th week, this 9th week second class, and each week we have about 5 lectures, each being for half an hour. And my name is Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing in the last class 41st one, I gave a lot of background, a recap sort of thing for the multivariate analysis concepts, mainly being the first one with the principal component analysis, and we are basically doing the factor analysis. So, then the factors, they would be factors depending on p number of variables which are there, which may be definitely dependent, and we take m of them such that we are able to give to the maximum possible extents by the rotation of the factors in such a way that predictability based on the factor plus an error terms would be there. Obviously, the error terms would be kept as low as possible in order to give the so called the maximum efficiency of the factors. But the word efficiency I am using in a very general sense, that you are able to predict, forecast or give informations from based on the factors. Let us consider an example. I will read the example, decide and give the results rather than going through the actual solution. I will come to that later on when we do the multiple linear regression. If you remember, I did discuss that I will be doing the multiple linear regressions in details, and before that there would be other background which I will come most probably by the 42nd or the 43rd class. As an example, let us consider the data set taken from Holzinger and Swineford 1939. The brief background of the study is as follows. 26 tests intended to measure a general factor and 5 specific factors were administered to the 7th and the 8th grade students in 2 schools. So, there are 2 schools, you want to basically have some factors based on which you want to study. So, the study would have been, say for example, background can be whether their parents are educated, whether they have higher degrees or the income bracket from which they belong. So, whether they have some effect. It could have been like whether they have sibling, older sibling, younger sibling, whether they live in a joint family, whether they live in a nuclear family, all this could have been taken, and there are different psychological studies, sociological studies which may be considered when you want to find out some objective criteria based on which you can comment on the factors affecting some output. So, the output could have been the performance of the students. So, output could have been, say for example, the general mental balance of the students. So, all these could be considered. So, let me continue reading it. So, these 5 specific factors were administered to 7th and 8th grade students in 2 schools, namely the Grand White school where the total sample size was 145 and the Pasteur school where the sample size was 156. So, this 145, 156 or whatever the sample size is from 2 different schools has would not basically be the same. It could be different obviously as it is in this example. It could have been that Grand White school numbers of observations could have been higher with respect to the Pasteur school, and all these things are possible. Students from the Grand White school came from homes where the parents were American born. So, this what if you remember I mentioned the sociological, the genetic factors could be there, from which background they are coming, income and all these things are there. Students from Grand White school came from home where parents were American born, while those from the Pasteur school were from homes of parents who were foreign born. Data from analysis includes 19 tests intended to basically understand 4 main domain set of information for the students, namely which are spatial ability. Spatial ability would be basically the visual perception of trying to understand geometric figures and whether they are able to tell actually as it is. There would be the concept of verbal ability, how they are able to express them in words, whether they can understand the meaning of simple words, understand the meaning of simple spelling mistake, whether they are able to at least mention that in words what they want or what they are trying to express. So, it could be paragraph comprehension, as I said, related to the logical thought process being expressed in words. They could be comprehension reading, they could be sentence completion, sentence writing, trying to find out the error in the sentence, word classifications, antonym, synonym, meaning of a word. They could be basically speed of reading also. So, third specific factors or the main criteria could be speed related to how you can do the addition, subtraction, you can count in groups, whether you can do your normal activities of trying to keep your plate in the basin if you are a kid. So, this is basically for the kids 9th and 7th and 8th standard, whether you are able to clean the plate as required, whether you want to basically able to eat it properly without much wastages. So, all these things are noted and how fast you can do it. So, how you can count the group of dots, join the group of dots, whether they are a straight line, curved line, and so on and so forth. And the last effect of the factors or the main criteria of concern or study would be memorizing or memory. So, whether you can do word recognizing from the past, sentence recognizing from the past, whether you can understand a figure, you can understand, say for example, number plates of car, phone numbers, to whole names, and all these things would be there. So, it can be related to how you correlate between figures and words, figure written in numeric and the words written in the numeric in the alphabet form, whether you can make a one-to-one corresponds to that. For the factor analysis study, consider 24 psychological tests. So, these are the actual tests which is x1 to xp and they may be independent or independent. So, but we will consider they are dependent. So, the psychology test is administered to the first group of students, which is 145, which is from the Grand White school. So, let us start with m is equal to 5. So, we want to basically find out of these number 24, which is p, we want to find out which 5 in case they give us the best results, such that one obtains the following table, which has all the relevant information such as estimated factor, loading, communalities, specific variances, all these things are there. So, what we are doing is we are taking 5, then it could be 7, that can be 9, that can be 15. So, as an example I am giving 5 such that one can utilize this information to understand what is the factor loading should be there in order to get the maximum amount of information which is required, given the fact there are in this case 26 random variables x1 to x24 random variables x1 to x24, which can basically give us the maximum amount of information from the data. So, these are the estimated factor loadings. So, if I find out the factors f1 to f5. So, for the case of visual perception, so these are the categories which I have already done, the visual perception, cubes, paper, from boards you can formulate, you can have general information, paragraph comprehension, sentence. So, these are I am writing them one group at a time in the sequence. So, in the next set of effects based on what we think are important factors, I will not use the word factors, basically on the important so called reasons and which are the outputs. So, it is basically paragraph comprehension, sentence comprehension, word classification, word meaning, additions and all these things, and the factors f1 to f5 are given, corresponding to that you have the errors and basically you can pass judgment accordingly. So, let us continue. So, in the same way you have the code, counting dots, straight curve, capitals, word recognition, and again the corresponding factors f1 to f5 are given in the second column, third, fourth, fifth, sixth, seventh, fifth, sixth, f1, f2, f3, f4, f5, and the errors and the corresponding other values are also given in the last two column. So, cumulative proportions if you want to find out. So, once you do the studies, cumulative proportion of the total sample variances, and that means what is the overall effect, you are able to find out the eigenvalues are given correspondingly, and obviously, we will see that they are in the decreasing number. So, the first factor would be 8.1354, then 2.096, 1.6926. So, these are the values. And the cumulative proportions based on which you can predict the variances, the variability. Let me use another color. So, there are cumulative proportions of total sample and variances as given as I am only reading the percentage wise 33, 42, 49, 55 and 60 based on the factors F1 to F2. So, obviously, you could have the factors of F1 to Fn. So, calculations would be done accordingly, your eigenvalues would be calculated, and then the cumulative proportions of the total values would also be found out. Now, if you want to find out the differences between the so called sample related variance covariance and the factors. So, that will will give the variability in the sample variance. One is not able to explain using this m is equal to 5. In case of m is equal to 15, then the cumulative proportions goes up to about 88% from a value of 60%. So, the values which you saw, it was 60% from 5, in the case of 15 it will be 88. But the reason, so obviously you will be tempted to use more and more factors, but it will basically depend what is the marginal so called values you are getting as you keep adding one variables at a time, factors at a time. So, to what level you should go such that you are able to give the prediction to the maximum possible level. So, one can also use maximum likelihood methods to get the solution, and we request the readers basically they can do some solve the problems on their own to get a good understanding on the maximum likelihood method as it can be utilized, and based on that you can compare the factor loading method which we have just discussed. Now, with this considering principal component and factor analysis, I will just change the topic and come into general utility analysis and decision making. Again come back to this concept of multivariate statistics later on. So, this would basically be clubbed as a decision tree or decision sciences area, and it will have some consequences how we are trying to analyze the multivariate statistics methods later on. I will give very simple examples without going to the details. So, different decisions, generally when we consider utility analysis of decision sciences, so we consider that different decision makers have different attributes for decision making. Attributes are characteristics. So, some of the characteristics can be objective, some of the characteristics can be subjective. They can be characteristics based on which we are taking the decision where the numbers are there. There can be other characteristics when you are taking a decision where no numbers are there. Say for example, I want to buy a car. I am giving an example, may not be actually relevant immediately. I want to buy a car. Then for me the cost factor, resale value, prices of diesel or petrol, whatever it is, or maintenance cost, all these things would be variables based on which I can take a objective decision. I am using the word objective and subjective not to basically give some color to or some value to the decision. Is basically I mean that I have some numerical values which I can assign to the objective and the subjective part. So, when it is something to do with numbers, they would be objective part, and such that the numbers would be easily communicable with the other person if he or she needs to understand why that decision is being taken. In case if it is basically a subjective one, obviously in that case rather than objectivity, subjectivity would be more important, like say for example, it can be the color of the car, it can be say for example, word of mouth best information set which you have received for the car when you are trying to buy that car. So, I am only considering the problem of buying the car. It could have been say for example, I want to basically find out how good or bad the school is. So, the school say for example, reputation would be very important depending on what the type of class 10 and 12 results are. So, in that case I would basically assign some numbers. So, the number of students who have received more than 95%, number of students who have received more than 90%, what is the number of students who have been admitted in the professional degrees after class 12, it can be chartered, it can be BCom, MCom, then it can be economics, it can be history, mathematics, somebody goes for the engineering one. So, all these things can be considered. In other case, say for example, I may consider the schools, how far it is from my residence, or what is the locality, is it a good one, or what is the actual fees based on which I am going to understand that what is the annual fees I have to pay for a kid's education in that school. It can be also, say for example, the quality of the faculty members, how good they teach, whether they have foreign degrees, or it can be whether they are willing to listen to the kids, or whether it may be, say for example, some of the parents thinks that a playground is very important. So, obviously, all those I will not use the word again factor. So, the criteria based on which I am going to take a decision can be both objective and subjective. Now, whenever I am taking a decision for decision where monetary outputs are there. So, I am going to consider now monetary outputs with where the numbers can be assigned. This concept would be more objective in nature now rather than bringing the subjectivity into the discussion. We will come to the concept where you analyze a decision making both considering both the objective and the subjective part would be taking up later. Some have the property, some set of persons who wants to take a decision has the property where he or she loves the risk, others can be whether they are indifferent to risk, and the third category can be that basically they are risk averse. Risk averse means they are willing to run away from the risk. The first set would basically try to go towards the risk, second category would be the set of people who are indifferent. So, each decision maker has with him or her an opportunity set based on which he or she is going to take the decision, and this opportunity set is specific to the person only. So, if the opportunity set for me is, say for example, x1, x2, x3, I am giving very simple connotations on from the vector perspective. Another person for the same set of decisions which are in front of him or her, the opportunity set based on which he or she is going to take the decision, whether following that combinations of x1, x2, x3 or not willing to take any of the decisions, obviously he or she would have a different so called preference number or the opportunity set. So, I am using the word preference, opportunity and so on and so forth interchangeably, you will understand it. So, whenever these cases are there, we need to basically analyze that there is some utility, some net worth of a decision process which needs to basically be followed such that we know that there is some objectivity in the decision which can basically be converted into numbers, and then decisions can be taken accordingly. So, consider this example, you have the outcome given in the leftmost column, which is 15, 10 and 15. So, these numbers which I have put are just theoretical. I will come to the actual usage of the numbers later on, they are just theoretical values. The second column gives me the corresponding probability. Now, it technically means for an outcome value of 15, there is a chance that it occurs out of the 100 such occurrences 1/3 number of the time, which is about 33.33% numbers of the total 100. Then if I go to the second column on the second row on the left hand side. So, it means that with the outcome value of 10, again the corresponding probability is 1/3, and finally for outcome of 15 the probability was 1/3. So, obviously you may be tempted to combine both for outcome A the first stage and the third stage, that means for which both the outcome value is 15 in both the cases. So, what is and the probabilities are 1/3 1/3. So, why did not we combine them? So, the answer I will say is in this way. These values of 15, 10 and 15 which you have are the actual so called numeric values based on which you as a third person are seeing that the decision maker is taking. So, the first 15 is, say for example, the amount of so called investment or the so called amount of money required, amount of numeric things which are required in order to facilitate the decision process. But what that value, first value of 15 has to me, for whom the probability is 1/3, and similarly for the third case, that when the outcome value is 15 and also the probability is 1/3. These two 15s may accrue different connotation for me as an investor or as a decision maker. So, if I am considering the first case of 15, it may mean that the actual conversion based on what my actual initial investment or initial values is 15, that total value of 15 can basically be considered as a decision which would give me a certain net worth, which would be definitely be different from the net worth which I am getting from the third decision, which means that values may be same, but the net worth for the decision would change from one decision to other. That is why I am basically taking them separately. So, the probabilities are 1/3, 1/3, 1/3. For the second decision maker, which is B, the outcome values are 20, 12 and 8, then out, and the corresponding probabilities are also again 1/3, 1/3, 1/3. In reality, the question is, what would a person or the decision maker do if he or she has two outcomes sets in front of him or her? That is the actual. So, obviously, these values of 15, 10 and 15 with the corresponding values of 1/3, 1/3, 1/3, this is one set, and then the other set means not the numerical set. So, not the arithmetic one, these are the decisions which I have. And for the set B or the second one, the outcome values are given as 20, 12 and 8, and the corresponding probabilities are 1/3, 1/3, 1/3. Now, these values for A and for B, these are the values which are apparent to a third party, but when the person is actually taking a decision based on 10, 15, 10, 15, 20, 12 and 8, the actual accrued value to me as a decision maker would be a some sort of functional form based on what is the input, which is basically 15 or 10 or 15 in the first case for A, and for the second case which is for B, it can be 20, 12 and 8. Now, when I need to basically find out the values based on which I as a decision maker I am going to take the decision, it would mean that there is some functional form based on which the input comes as the outcomes, which is the first column and the third column, and the end result which basically accrues to me would basically depend on what my outlook of so called decision making is, and what that outlook I will come to that within few minutes. So, in reality, what would a person do if he or she has two outcome sets in front of him or her? Now, when we basically try to analyze the problem, the best solution would be, the easiest understanding of that problem would be that you basically find out the expected value. So, the expected value would be given by the case when for the first case and in the next case for the second one. So, 20 into 1/3, 12 into 1/3, 18. So, what I need to find out is so called expected value for B, this is the expected value for A. You combine them and then basically take the decision. So, the values which are written here 15, 10, 15, 20, 12 and 8, this would basically depend on what my utility is or the net worth based on which I am taking the decision. So, I will come to that utility concept later on. Now, consider the same example, but with the different probabilities. The probabilities are for the 15, 10 and 15 for decision A, the probabilities are not now 1/3, 1/3, 1/3, now they are 50%, 25%, 25%, and corresponding to B again it remains that outcome values are 20, 12 and 8 and the corresponding probabilities are 1/3, 1/3, 1/3. So, in this case if I consider the so called expected value, the expected value would be 15 into half plus 10 into 1/4 plus 15 into 1/4, that would be for case A, and for case B it would basically be 20 into 1/3 plus 12 into 1/3 plus 8 into 1/3. Again you find out the expected value, but once you find out the expected value you have to basically rank them according to the expected value. So, now for A we have the expected value of outcomes given as 13.75 in this case, and for B it still remains 13.33. So, in the first case both the values were coming out with 13.33, hence we were indifferent, could not take a decision. In this case, as now A's expected value is 13.75 and B's continues to remain at 13.33. So, if our main task is to find out the best so called outcome, we will definitely take A into consideration. Consider a next example which is a different setting, like consider a game is being played and there is team A and team X and team Y, and obviously for each in this game these teams appear for two different tournaments. Consider the football one, the same set of teams play, say for example Santosh Trophy, and the same other team say for example plays some other tournament which is being held. Now, in that case for case 1 the points accrued for an outcome which is win, draw and loss, the corresponding points are 2, 1, 0, and when I compare that for case 2 the other tournament, the win, draw and loss our values are 5, 1, 0. Now, what we need to do is that basically try to combine the decisions. Before I combine the decision, I need to find out whether we are doing the calculations properly. So, in the first case what we will do for team X and Y, we will basically multiply the actual values of the so called values. Values means how many such wins are there, how many such draws are there, how many such losses are there, and for each corresponding a win, draw and loss for case 1 which is the tournament, I assign a point which is for to X would be 40 into 2 plus 20 into 1 plus 10 into 0. Similarly, when I do it for case 1 for team Y, it will be 45 into 2, 5 into 1 and 20 into 0. So, based on that I find out the points. When I do it for case 2 the second tournament, again it will be 40 into 5 now, because the rankings the point system for second tournament is different. So, it will be 40 into 5 plus 20 into 1 plus 10 into 0, and again in the similar case if for team B it will be 45 into 5, 5 into 1 and 20 into 0. So, with this I will end this 42nd lecture, continue discussion the utilities in the 43rd, 44th and 45th, and slowly build up that how we can use the decision concepts for the along with the utility theory for analyzing different type of decisions under the case where there are very specific examples in multivariate statistical methods. Thank you very much and have a nice day.